Example 12. A copper container of heat capacity 200 joules per Kelvin. Okay, notice that this is heat capacity, the big C, and not the specific heat capacity, the small c. If you look at the unit, the heat capacity, the unit is joules per Kelvin. That means if you want to get the number of joules, we just have to multiply this by the number of Kelvin. Okay, joules per Kelvin multiplied by number of Kelvin will give you the number of joules. That's why the formula is simply the big C times the delta theta. Okay, joules per Kelvin multiplied by how many Kelvin, the temperature rise, that will give you how many joules, the Q. Okay, then next we have also 0.20 kg of water of specific heat capacity 4200 joules per kg per Kelvin. Okay, this time we are given the specific heat capacity of water, the small c, and look at the unit, it's different, it's joules per kg per Kelvin. So if you want to find out how many joules, we multiply by number of kg as well as multiply by the number of Kelvin. Okay, that's why the formula, if the specific capacity is involved, the heat will be equal to the specific capacity multiplied by the mass, number of kg, as well as the number of Kelvin. Okay, initially they are at 20 degrees Celsius. This is the heat, 5000 joules of heat is given to them. To them, that means to both the copper as well as water. Okay, they ask us to calculate their final temperature. Okay, so first, the total heat supplied will be equal to the heat gained by the copper container as well as the heat gained by water. Okay, heat gained by copper container will be the big C multiplied by delta theta. Okay, we use big C multiplied by delta theta because the copper, we are given the heat capacity. Okay, then plus the heat gain by water. For heat gain by water, we use mc small c times delta theta. Okay, we use this formula because we are given specific heat capacity for water. Okay, sub in everything. This is the total heat supplied equal to, this is the big C delta theta. Delta theta is the change in temperature. So it's the final temperature minus the initial temperature. Okay, then plus the heat gained by water, we have mc delta theta. Okay, this time we multiply by the mass because this is specific heat capacity. Okay, so sub in everything, we calculate, we can get the final temperature as 25 degrees Celsius.